Have you ever, seriously wished you could just jump into the future? Well, guess what? Physics might actually have a one-way ticket for you. It's wrapped up in this wild idea called the twin paradox. And really, it's less of a paradox and more of a mind-bending but very real blueprint for an incredible journey. So let's get into it. Look, we've always dreamed of reaching for the stars, right? But there's this one huge, glaring problem. Space is just big, unimaginably, ridiculously big. To put that in perspective, our closest stellar neighbor, Proxima Centauri, is over 4 light years away. Even if we could travel at the speed of light, that's a 4-year trip one way. With the tech we have now, we're talking more than 70,000 years. That's not just impossible in a single lifetime, it's impossible for entire civilizations. So how could we ever pull this off? Well, the only way, really, is to travel at what are called relativistic speeds. That's a huge chunk of the speed of light. But here's where things get really weird. When you start moving that fast, the very rules of the universe, including time itself, start to stretch and bend. This crazy effect has a name: time dilation. It's a cornerstone of Einstein's special relativity, and what it means is that time isn't this constant universal clock ticking away for everyone at the same rate. Nope, your speed through space directly affects your speed through time. To put it simply, the faster you move, the slower the clock ticks for you compared to someone just standing still. Now, I know this can be kind of hard to wrap your head around. So to make it more personal, let's use a classic thought experiment that really brings this cosmic concept right down to earth. Let's talk about the twin paradox. Okay, so the setup is super simple. Imagine we have 2 identical twins. One is our stay-at-home twin, and they just hang out on Earth. The other twin is our astronaut. They hop into a super advanced spaceship and just blast off towards a distant star, traveling at almost the speed of light. Once they get there, they turn the ship around and come straight back home. And this is where things get absolutely nuts. For the astronaut on the ship, because of that time dilation we just talked about, the whole round trip might only feel like a few years. They've done it, mission accomplished, and they're back to see their family. But on Earth, decades, maybe even centuries have flown by. The astronaut steps out of their ship into a future where everyone they ever knew is long, long gone. Now, this is the exact point where your brain probably goes, whoa, hold on a second. This is the paradox part. From the astronaut's point of view, inside that spaceship, aren't they the ones who are stationary while the Earth is the one that's rocketing away from them? I mean, Einstein said all motion is relative, right? So shouldn't the twin back on Earth be the younger one? It's a fantastic question, isn't it? If motion is all relative, the whole situation feels like it should be perfectly symmetrical. So why is there a real physical difference in their ages? What's going on here? Why is it only the traveling twin who gets to cheat time? And here's the solution. It's beautifully simple, actually. The situation isn't symmetrical at all, not even close. While their relative motion might seem the same, their actual physical experiences of the universe are fundamentally different. Just think about what the astronaut twin actually goes through. They have to accelerate like crazy to leave Earth. Then they have to de-accelerate to turn around at the star, accelerate again to head back, and finally de-accelerate to land. All of that pushing and pulling, those immense forces, that constant changing of velocity is the absolute key. Meanwhile, the twin on Earth, they experience none of that. They're not being crushed into their seat by G-forces. Their journey through what physicists call spacetime is smooth, constant, and uninterrupted. They're just coasting along in a single, stable frame of reference. You know, the best way to visualize this is to imagine their paths not just through space, but through the 4-dimensional fabric of spacetime. The Earth's twin travels what is essentially a straight line, but the astronaut, with all that accelerating and turning around, takes a much more bent or curved path. And that difference in the shape of their paths, well, that changes everything. Okay, now here's the part that's gonna flip your intuition completely upside down. In the normal, everyday geometry we all learned in school, the shortest distance between 2 points is a straight line, right? Of course. But in the wonderfully weird geometry of Einstein's spacetime, the exact opposite is true. The straight line is actually the longest possible path you can take. And that right there is the solution. Because our astronaut twin took that bent, roundabout, shorter path through spacetime, they literally experienced less time. The length of your path through spacetime corresponds one-to-one with how much time you actually feel passing. Shorter path, less time. It's as simple and as profound as that. So you see, it was never really a paradox. It was just our intuition getting tripped up because we don't experience these effects in our daily lives. The acceleration is the crucial difference maker, and it leads to a real, measurable change in how fast you age. This isn't just a fun thought experiment, it's a fundamental feature of the universe we live in. So, what's the bottom line here? The big takeaway? Well, first, the twin paradox is a totally real effect. If we ever send an astronaut on an interstellar journey, they absolutely would return to an Earth that has aged far more than they have. And that leads to this staggering conclusion. One-way time travel to the future isn't just science fiction. It is physically possible. Which, of course, leaves us with one final, very personal question to think about. To see what humanity becomes, to witness the future, but knowing you'd have to leave everyone and everything you've ever known behind forever. If you were offered that chance, that one-way ticket, would you take the trip?